Hello everyone, next come to this some example on beta or gamma function. Okay, let's take down. Prove that gamma of 1 by 2 is equal to square root of pi. It's a very important question. They will ask for 2 marks. Okay, gamma, prove that. Once again I will explain the question or proof. Prove that gamma of 1 by 2 is equal to square root of pi. Okay, let's see the proof. We know that the relation between beta and gamma function is beta of mn is equal to gamma m into gamma n divided by gamma of m plus n. Okay, see here, for proof the in LHS we have a gamma of 1 by 2. That's why I'm taking for a beta mn value as a 1 by 2. Taking m and n as a 1 by 2, then what to get? Beta of 1 by 2, 1 by 2 is equal to gamma of 1 by 2, gamma 1 by 2 divided by gamma 1 by 2 plus 1 by 2. Okay, in RHSC, gamma of 1 by 2, gamma of 1 by 2, it's a 2 times. That's why I'm taking gamma of 1 by 2 square root, sorry, square, it's a square, and the gamma of 1 by 2 plus 1 by 2, 1 by 2, 1 by 2 is a once again 1, gamma of 1. We know that gamma of 1 is a 1. Then remaining part we have to get beta of 1 by 2, 1 by 2 is equal to gamma of 1 by 2, its square. Okay, but we have to prove gamma of 1 by 2. That's why I'm taking solving the LHS part only, considering the beta of 1 by 2, 1 by 2 is equal to, you know the definition of the beta function, it's a integration 0 to 1 x to m minus 1, 1 minus x to n minus 1 into dx. See here, m n value is a 1 by 2. That's why I'm putting integration 0 to 1 x to 1 by 2 minus 1, 1 minus x to 1 by 2 minus 1 into dx. Okay, then 1 by 2 power 1 by 2 minus 1 is once again minus 1 by 2, and the power of 1 minus x, 1 by 2 minus 1, 1 minus x is 2, it's a minus. Make it correction here, some print mistake on textbook. Take as a 1 minus x power is as a minus 1 by 2. Okay, x power is also minus 1 by 2, and 1 minus x power is also minus 1 by 2. Okay, we know that in beta function m n n must be strictly greater than 0, must be the power of x, and 1 minus x must be a positive, but we get here a negative, then it does not satisfy the beta function. That's why I'm taking once again as x is a sine square theta, because the power of x in the form of 1 by 2, if you take 2 we get a cancel the power. Okay, that's why I'm taking x equal to sine square theta. Then what is the differentiation? Dx is a 2 sine theta. Then sine theta differentiation is cos theta, and theta differentiation is a d theta. Okay, as a variable changes, limit is also changes for an integral. That's why I'm taking, put x equal to 0, we get a sine 0 when if the theta equals 0, and x equal to 1 when the theta value is a pi by 2. That is the sine pi by 2 is a 1, sine 0 is a 0. Okay, put that value in the RHS part of the beta function. Then beta 1 by 2, 1 by 2, what to get? Integration limit is 0 to pi by 2. See here, the x value is a sine square theta. Putting the 2 to the power cancel, we get only sine, the power is minus 1. That's why I'm taking as a reciprocal 1 divided by sine theta. And once again, for a 1 minus x is a sine square theta, 1 minus sine square theta is a cos square theta. The power 2 get cancelled. The cos power is minus 1. The reciprocal, the 1 divided by cos theta. The remaining part dx is a 2 sine theta cos theta d theta. Okay, then sine theta cos theta get cancelled. We get to only the 2 is a constant, take outside. The remaining part is what? Integration 0 to pi by 2 d theta. Once again, the integration d theta is what? Theta. Apply the limit. What to get? Now we get a 2. The pi by 2 minus 0. Then 2 get cancelled. We get a pi. That will put in the upper equation, that is the beta of 1 by 2, 1 by 2 is equal to square gamma of 1 by 2, its square. Okay, put that value in that equation. What you get? Gamma of 1 by 2 squaring is equal to, we get a pi, then gamma of 1 by 2 is equal to square root of pi. So this is the proof of the standard formula. It's a very important, they will ask for 2 marks. Okay, let's see one more. Prove that integration 0 to infinity e raised to minus x square into dx is equal to 1 by 2 square root pi. Okay, see here, if the limit the power is 0 infinity, must and should you have to use gamma function, if the limit of integral it is in the form of 0 to 1, must and should you have to use beta function. Okay, so here it is in the form of 0 to infinity and the function is e raised to minus x square. But we know that what for a gamma we have in the form of e raised to minus x. That's why I'm putting x square is equal to z to the nth variable, then differentiate that x square is a 2x and x is a dx and z is a dz. Okay, then dx is equal to what? Dz divided by 2 square root z. Okay, let's see next one. And the limit, as the variable changes, the limit is also changes. That's why putting x equal to 0 we get a z equal to 0. If putting x tends to infinity we get a z tends to infinity. Okay, and then apply that data on the LHS part. Then what we get? Integration 0 to infinity e raised to minus x square dx is equal to, the limit is as it is 0 to infinity e raised to x square is the e raised to minus z and dx is dz divided by 2 square root z. Okay, 1 by 2 is a constant, take outside, the remaining part is what? Integration 0 to infinity e raised to minus z, z raised to minus 1 by 2 into dz. Okay, 1. It is in the form of what? Gamma function. See here in right side, gamma of n equal to integration 0 to infinity e raised to minus x, x raised to n minus 1 into dx. It is a gamma function. If you put n equal to 1 by 2, what you get? The minus 1 by 2 can be rewritten 1 by 2 as a constant, take outside. The limit is integral 0 to infinity e raised to minus z as it is. The z raised to minus 1 by 2 can be rewritten 1 by 2 minus 1 into dz. Okay, by applying the definition of the gamma function, n value is a 1 by 2. That's why we get 1 by 2 into gamma 1 by 2. Once again we know that by the previous proof, gamma of 1 by 2 is the square root of pi. That put in the value we get a square root of pi divided by 2. So this is the proof. Okay, it has some corollary. Prove that, next one, prove that integration minus infinity to 0 e raised to minus x square into dx is equal to square root of pi by 2. Okay, see here, if you take it is if you taking the, it is also, if the limit is 0 infinity and it is in the form of e raised to minus x square, then you have to take it is a x square equal to z. But we know that already if you taking x square equal to z, we have know that the value is the square root of pi by 2. That's why I'm taking as a changing the limit value only. Okay, for previous we prove integration 0 to infinity e raised to minus x square into dx is equal to square root of pi by 2. See, for a corollary you have a minus infinity to 0. Simply you have to changing that limit. Okay, that's why I'm taking x equal to minus z, then dx is what? Minus dz. As the limit is x tends to minus infinity, what you get? Z tends to infinity and x equal to 0, z equal to 0. Then what you get limit? Put that value, integration minus infinity to 0 e raised to minus x square dx is equal to infinity to 0, e raised to minus, put x equal to minus z, we get a minus z square and the dx is the minus dz. Okay, take minus outside, we have to get infinity to 0 e raised to minus z square dz. But we know that what? See here, integral 0 to infinity e raised to minus z square dz, replacing the z as a x, or directly you have to put the similar in the form of, it is in the form of you have to take any variable, but the format it must be in the form of e raised to minus, if you take y, e raised to minus y square into dy, it is also square root of pi by 2, or z, take any of the variable. If you take standard formula, I have to take as a x. Okay, integral 0 to infinity e raised to minus z square dz, the value is once again a square root of pi by 2. So this is the proof. And take next corollary, prove that integration minus infinity to infinity e raised to minus x square into dx is equal to square root of pi. Already you know that integration minus pi to pi minus infinity to infinity can be rewritten in the form of 2 into integration 0 to infinity. That's why I'm taking the standard property of the integration. Consider first LHS part, integration minus infinity to infinity e raised to minus x square dx is equal to 2 into integration 0 to infinity e raised to minus x square into dx. Okay, already you know that by the previous proof, integration 0 to infinity e raised to minus x square dx is the square root of pi by 2. 2 get cancelled to the square root of pi. So this is the proof of the corollary, second corollary. Okay, see next examples. See here, show that beta of 1 by 2 1 by 2 is equal to pi. Okay, if they have a see, if beta of 1 by 2 1 by 2 can be expressed in the form of standard value or some constant finite value, then you have to apply relation between beta and gamma function. Okay, see here, we know that beta of mn is equal to gamma n divided by gamma m plus n. See here, putting the for a 1 by 2 n by 2, then the m value is 1 by 2, n value is 1 by 2. What do we get? Beta of 1 by 2 1 by 2 is equal to gamma 1 by 2 divided by gamma 1 by 2 plus 1 by 2. Gamma 1 by 2 is the square root of pi, and gamma 1 by 2 plus 1 by 2 is a gamma 1, that value is a 1. Then square root of 2 times we get a square root, square get cancelled, we get a pi value. So this is the example. Okay, it has some standard example on beta function. It is left to you guys. Next class I will explain this example. Okay, thank you.